Hello class, this is the calculations for the surface area of composite solids. You'll quickly notice that this is more time consuming because there are more calculations, but we're still working on smaller portions at a time. So let's follow along, and here we go. So the first thing we need to think about is how many different faces are there? So I can see one. As before, we saw the area of this trapezium. I'm going to call this one area 1. So let's do that one first. Area 1 in the front. This is going to be, well, we've already got it here, but for completion's sake, let's write out all the formulas. So height over 2 times the top and bottom, so the two parallel sides, which is 9 plus 12. I already have that calculation here. It's going to be 42. That's 42 centimeter squared. Put that in the box because we're going to need to pull that up later in our calculation. The next calculation I can see, the easiest ones I can think of, is this rectangle in the back here. I'm going to call that area 2. So area 2 is that rear rectangle. Area 2, that's just going to be 4 times that 7. So 4 times 7. So area 2, 4 times 7 is 28 centimeters squared. Once again, putting that in the box because we need that for later as well. The next easiest shape, again I can see, is this bottom rectangle. It's underneath. Let's call that area 3. Underneath. So area 3, that's just going to be 12 times 7. So 12 times 7. Area 3 is going to be 84. 12 times 7, yep, sorry, 84 centimeters squared. Just did a quick mental calculation there. I can see another rectangle on the top here. That I can see to be, well, that's going to be 9 times 7. Let's call that area 4. And I hope you're already seeing with surface area of composite solids, there's a lot more to calculate. So area 4 is 9 times 7. Once again, 9 times 7. Area 4 is going to be 63 centimeter squared. So looking very carefully, we have this trapezium, which we're going to double later on, front and back. We've done this rear rectangle. We've done this bottom rectangle and this top rectangle here. The last shape, I hope you can see, is this shape here. It could be a square, but I've made it that this is actually a rectangle. So this is going to be 7 times this length here. I'm hoping you can see that there's already a problem in having to calculate this. It's that we don't have this length here. But in order to calculate this length, we need to take it from this right angle triangle. So we have a problem within a problem. Let's do this as well. So now I'm going to draw out that shape here. So let's draw out that shape. We have 4 on this side. That's 4. We're trying to figure out what x is. Let's call that x. And this side here, well, if the full length is 12 and 9 cuts off at this point here, we can see that this length, which matches the one we have here, that is just 12 take away 9, which is 3. So now using Pythagoras, we can see it's going to be 4 squared plus 3 squared equals x squared. Solving for x, we get x squared equals 25, just putting that into your calculator. So x equals plus or minus 5. But because we're working with length, we only take the positive. And so now area 5 we're up to is going to be 7. Let's label this now. Area 5 is going to be 7 times the 5 which we just calculated. So 7 times 5 equals 35. And so now the total surface area, so surface area is going to be, and being very careful now, we saw that it's 2 lots of area 1. So we need to multiply this one by 2, which will give us 84. 84 plus the rest of them. I mean, just for completion's sake, I'm just going to write all of them out. So plus 28 plus 84 plus 63 plus 35. So the surface area is all of that in the calculator. It's again much faster if it's in a physical, so physical calculator. 28, 84, 63, 35. So the total surface area of this is 294. Is it in centimeters? Yep. Centimeter squared. And that is our final answer. So yeah, I hope that gave you an insight into how we can break down the surface area of composite solids. Hope to see you in the next video, and best of luck.